Okay, now we're going to look at absolute value inequalities. And these are going to seem a little strange at first. Once you get through the first step, they're pretty straightforward to solve, but make sure you get the first step down right. So the definition here is you have the absolute value of a variable is less than or equal to c. Okay, getting back to this. So if the absolute value of x is less than or equal to a constant, that means that the value of x, the variable x, is either smaller than or equal to that constant or larger than or equal to the opposite of that constant, which probably makes no sense. So let's look at an example here. If the absolute value of x is less than or equal to 3, we need numbers that are smaller than 3, but only down to -3. Because once you get to -4 is smaller than 3, but the absolute value of -4 is +4, and 4 is not smaller than 3. So if the absolute value of x is less than or equal to a constant, that means x is in between that constant or the negative of that constant. Whereas if the absolute value of x is greater than or equal to a constant, that means we've got an or situation. Either x is greater than or equal to that constant, or x is less than or equal to the opposite of that constant. Both of these are assuming the constant is a positive number. So again, if the absolute value is greater than or equal to 2, that means we either want the numbers bigger than 2 or the numbers smaller than -2. So again, if you take -4 here, the absolute value of -4 is +4, and +4 is greater than or equal to 2, so it meets the condition. Okay, solving absolute value inequalities. Again, you get the first step set up right, and then it's just like the problems we've been working. So if they have the absolute value is less than the number 9, then that means this particular expression is either smaller than the 9 or bigger than -9. And then we solve it like a three-sided equation. Add 1 to all three sides, divide all three sides by +2, and we're left with x is in between 5 and -4. Whereas if we've got the absolute value is greater than a constant, then the expression is either greater than that constant or it's less than the opposite of that constant. This one's pretty easy to set up. Basically, you just drop your absolute value signs and you get this half of it. For the other one, you want to change the 7 to a -7, change the sign on the constant, and then change the direction of the arrow. And then we can solve for x. And this one's going to be an or statement. Either one side or the other can work. So either -infinity to -5 or the interval from 9 to infinity. And just a couple story problems we can set up just so you get a couple more examples here. Out of the way. Okay, so we're going to rent a car. We've got two options. Either we can go to Company A, they'll charge us $42 up front and then plus 5 cents a mile. Or if we go with Company B, they're going to charge us only $34, but they're going to charge us more per mile, 14 cents per mile. So we're wondering what conditions make it cheaper to rent from Company A. So the more miles we drive, the more promising Company A's deal looks because it's less per mile. But if we're only going to drive a few miles, Company B is going to turn out to be cheaper. So to set this up, we're going to let x be the number of miles the car's driven. Company A, the total cost is going to be $42 plus $0.05 times the number of miles. Company B, our total cost is $34 plus $0.14, 14 cents, times the number of miles. And then what we're trying to do is find out when is Company A's cost less than Company B cost. So that would be solving when is 42 plus 0.05x less than 34 plus 0.14x. And then another application. According to the NCAA, the length of a football should not vary by more than 9/32 of an inch from 11 and 5/32 inches. 5/32 of an inch. So a football, the ideal length of a football is 11 inches and 5/32 inches. So, but of course every football is going to be a little bit different. So if we let x be the length of our actual football that we're going to play the game with, we want the difference between the actual length of the football and the ideal length to be less than or equal to our fudge factor here, 9/32 of an inch. And we can solve from there.